All right, let's get started. Good morning, everybody. Good to see you all on here. Let's see if this works. Yeah. Good morning. My name is Rob. I'm a DevOps consultant at Xperiod, and I would like to take you on a tour on security aspects of using GitHub Actions. I've been using GitHub Actions since they came out in 2019. And well, when you start working with them in the real world, especially if you're in an enterprise organization, you need to think about all the security aspects of using actions. And when you use continuous integration, continuous deployment, pipelines, and stuff like that, it's very important to be aware of what can happen when something runs. So in this case, we'll look at what happens when the pipeline runs, who has access to the code in your repository, who has access to the keys that you use to deploy something into production. We'll go over each of these aspects with GitHub workflows, and I'll show you what to look for and how to improve your security stance without locking every DevOps engineer out. For this session, I assume you know a thing about or two about Git and GitHub. I'll dive straight into GitHub Actions. On the lower left-hand side, you'll see my GitHub Twitter handle, so please reach out if you have any questions or follow-up stuff. And you can find my blog there and my GitHub user repository with a lot of information on top about me. I'll also share the slides afterwards, so you can always look something up, because I've got a couple of links in there that might be interesting, so you know where to find them as well. But before we get started, well, the naming in GitHub, it can be a little bit confusing. I want to make sure that we're on the same page. Let's talk about actions and workflows that are running the actions, because I'm talking about a lot about workflows in this session. It's helpful to have the same vocabulary, of course, for everybody. Well, the workflow is the thing that is being triggered that executes one or more of your actions. And a workflow can be triggered by loads of events inside of GitHub. For example, when somebody pushes new code into your repository, creates a comment on an issue, or even creating an issue or a release, can all be triggers for a workflow to get started and to be triggered and run for you. Then the actions are the steps in the workflows. They can be grouped in jobs, and they are the things that are actually doing the work for you. And the real simple basic action is, of course, just run something in a shell script and do something for them. You have multiple opportunities to run GitHub Actions. You can create your own actions, or you can use an existing one from the marketplace, because there's a lot of actions available. Last time I checked, there were more than 70, I believe. Something that they need, and wrap that in an action, so you don't have to do that yourself by, for example, using a shell script and figuring out everything yourself. They're very easy to use. This is an example of a workflow file. It needs to be in a .github/workflows folder. That it needs to be workflows, plural. If you save it in workflow folder, you will be scratching your head for half an hour figuring out why it isn't working. It needs to be in that exact location, otherwise it will not work. It's a text file. It's YAML that has a convention of some spacing around it. And in this case, I'm triggering this one when somebody pushes code into my repository and pushes that up to GitHub. In it, I'll start a job. I named it build and deploy here. It targets an environment that has a label, and then the job contains one or multiple steps. In this case, I'm using the default, basically the action that everybody uses. We check out our code so we can do something with it. The next step, and then goes through my code, make sure that I have the right version of .NET Core set up, because this project needed it, a specific version. And then I run a .NET build command on my project. So this is a really simple example of a workflow. So now that we at least have the vocabulary right, so we can get started with actual security stuff. I will dive deeper in this session on repository security, everything that you need to know about your runners, all the things that are coming back to mind when you think about actions and how secure they are and how you can run them securely. And I'll end things with forking actions and making sure that you keep it up to date. That's the best practice that I could find to do this securely. And I'll explain what that means later on. So getting started with repository security, let's talk about who has access to your code. Well, you have different access levels that you can set inside of GitHub, and you can set them at 3 different levels. Either the repository level, that's the lowest level. Everybody already has an organization, that's basically your user, but you can create organizations as well, even on github.com. And if you are running on GitHub Enterprise, you have an enterprise level where you can set access levels. And for example, you can then set access levels for everybody in all the organizations inside of your enterprise. There are different permission levels that you can set inside of GitHub, going from, of course, no access, then you cannot see anything at all. But if you're running on github.com on a public repository, then everybody who has an authenticated session with github.com, so a logged in user, already has read-only access to public repositories. For triage, you have a little bit more access on top of read-only. You can also manage issues and pull requests from that. Well, write access is, of course, straightforward. And then the maintainer is an interesting one because that has, on top of the write actions, some additional authority that it can do. Like, for example, editing a repository description. They can enable a wiki or other options as well. But they don't have anything that is sensitive, like, for example, viewing security scan alerts. And they cannot do destructive actions like delete or transfer repository, or even delete packages or releases. And then you have the admin level that has full access. Next, I want to talk about workflow secrets. How can you, what do you need to know about using them? You can include them in your action, in your workflow files. You can create them on the repository level or the organization level. In this case, you can see I created two, publish profile and Sonar token. And then in your YAML, you can include it with the dollar accolade, and then secret.publish profile. You can already see that they're not case sensitive, so be aware of that as well. And then you're good to go. You're now injecting the secret value into your workflow run. Well, what are those secrets even? They're actually secrets. Some other CI/CD systems have two-way encryption and decryption, and you can read those secrets in the user interface, for example. And if you have the correct rights, you can get to that value. That's not the case inside of GitHub. They're always encrypted client-side before they're being sent to GitHub. So when you use the UI, they're being encrypted with the public key for your organizational repository, and GitHub manages that completely for you. It's completely transparent. And keep in mind, one step back. When you use the REST API, you can, if you have the appropriate rights, you can use the REST API to fetch the public key, encrypt the value of the secret before you send it in, and then you post the encrypted value back into the GitHub API. And they're actually, therefore, secrets, and they're being sent over the wire fully encrypted. GitHub has, of course, the private key, and they can decrypt it on their end, but you cannot get access to the private key, so you can never decrypt that value. And if somebody then forks your public repository over, keep in mind that they only are forking over the code that is in there, and the secrets will stay where they belong because they're your secrets and they don't belong with the fork, of course, at all. So relatively, workflow secrets are secret and good to use. Looking into who has access to your secrets, you need to think about these two levels. If you want to create them at the repository level, then you need to be repository owner. So you have to have full access to the repository. If you want to create them at the organization level, you need to have admin access to the entire organization. So for creating them, you need to have very high level rights. But then everybody who has the correct rights to do something in a workflow can use them, but they cannot change, edit, or delete it. The nice thing of adding them at the organization level is that you get extra access policies. So you can share secrets with all the repositories in your organization, or just private repositories, or even specify which repositories can use those secrets. So that's good to know. As I already said, they're encrypted until you start using them in your workflow. They're injected as either an environment variable or as direct input into a shell command, for example. And GitHub will try to redact the values of your secrets in the logs. They use a regular expression for that, where they hunt down the value of your secret, and then star that out in the output. And that's already server-side, so it will not be done client-side, of course. That's the way to keep things secret. So if somebody looks at the logs, it will only see those stars. But because they're using a regular expression, you need to think about it. And that's why we say don't use structured data like JSON or XML in your secrets, because those are very hard to redact. Thinking about JSON, there's a lot of spacing in there, and there's a lot of colons in there. And hunting that value down with a specific regular expression is very hard to find. So if you really need to use JSON, then make sure there's a single line string and remove all the spaces from it. Then it's a rather normal string instead of a special one with line endings in it and everything. And then it probably will be redacted in the logs, but be very careful with that. What do I mean with that? Well, when you're injecting the secret value into your workflow, any action can do with it what it wants. And therefore, I say anyone who has read access to the action logs, excuse me, should be considered to have access to the secrets. Here's an example of a workflow file that I have that runs a shell command that says echo my secret value. And the first one is the normal one that will be starred out in the output. The second one is interesting because that one puts a space after every character in the secret. And when you look at the workflow logs for this one, you can see on line 6 here, the first one is being obscured. It has stars in it. And the second one all of a sudden is readable in plain text. So now there's a very easy way that an action or your own shell script could leverage to still spool those secret values out into your logs, or even send them somewhere else, of course. So that's why I say best to treat them as public, have an external mechanism, like for example a key vault, where you use the real secrets and then have some key rotation around it that makes sure that the value that you're using is only valid for the duration of the workflow. So secrets are relatively set up good, but you can still really easily do some damage with them if you're using them wrong. Just give me a sec. All right, let's look into your own code in the repository, because that's also one of the things that you need to think about when you're talking about repository security. And with that, I mean really anything in your repository. Your workflow files, shell scripts that you're using in there, your own code, and even all the dependencies throughout all those files. If you're using workflow files that are running in containers, you need to watch out on the containers that you're using and all the image layers that are in them. We're all building on top of the shoulders of giants, as we say. We don't reinvent the wheel for everything that we need. We use a package library from some package manager. Those are a dependency as well. You need to verify what's in them as well. As a best practice, at least start with making sure that you're checking out your own code for known vulnerabilities or weird patterns, SQL injection, stuff like that. Run some static code analysis on your code, on your own code, but also on anything that you're using. Especially when you use third-party dependencies, and I guess everybody does that. And we've seen research in the field that for a lot of open source projects who are already leveraging third-party dependencies. There's at least 70% of what they're pulling in as third-party dependencies, and they say 70% of the code isn't even from that repository itself. And if you use an SDK and use a real-world product, and you're building an application yourself, and you start scanning that and watching for lines of code, for example, and you find that 99% of your code isn't even yours. So scan it, everything for known vulnerabilities, and make sure that you can act on them. That means you also have a process in place that will keep your dependencies up to date to make sure that you're always up to speed with all the latest security updates, for example. So think about that as well when you talk about repositories and security. The nice thing is that all the changes to your code and your setup inside of GitHub is available. Well, for code and files, it's of course available in the Git commit history. So that's already been handled by Git. But everything around your code, on all the files in your repository, is available in the audit log. And the audit log can be found on the enterprise level by going to, or an organization level by going to settings and then to the audit log. And there you find everything that you want to know around changes on your anything but code. Who has given somebody access right? Who has created a secret or changed it? Who has created an access token? What scope does it have? And even down to who has enabled a feature on a repository. Everything is in there. And if you're a normal user account on github.com, then you can go to your user profile, go to settings, go to the security log, and you have access to the same information as well. All right, that's it for repository security. Let's dive deeper into the runners that are executing your actions. Well, there are two different options. You can use a self-hosted runner that you host yourself somewhere. On the top right-hand side, I've got a runs on self-hosted. That's just a label that's being used as a convention to know that it's a self-hosted one, but you can use any string for that as well. And the bottom one runs on Ubuntu latest, and that is one that is being hosted by GitHub. That's a default tag for running on Ubuntu. And a nice differentiation between these two is when you install them on as a self-hosted runner, you're installing them on your own virtual machine somewhere in your own cloud, or maybe even on premises, and you host it yourself. That also means that all of a sudden keeping that virtual machine up to date and secure and tied down is your responsibility. You need to be aware of what the runners will have access to. It does give you an opportunity to leverage a specific environment setup. So, for example, you have some tooling or some third-party packages that you're using, and it needs to have a license installed or something like that. That's ideal. That's an ideal use case to run on a self-hosted runner. It also means that you don't have any usage limits. If you run it on a GitHub hosted runner, you're paying by the minute, but you have a bucket of 3 minutes in every tier that you're paying for. Because all of a sudden, then keeping the operating system and the tools up to date and paying for the compute is now GitHub's responsibility. So having no usage limits on self-hosted runners could be an argument to run them there, but keep in mind that you are now responsible for making sure that that setup is secured. When you're running on a GitHub hosted runner, each and every execution of your workflow will get a clean environment with every run. They, of course, don't want to reuse the same disk space between different customers, of course, or different users. And they make sure that you get a clean execution environment with every run. It also means that when you're pulling in dependencies, that you always need to pull in all the dependencies, and you cannot just out of the box leverage a cache. There's some ways around that, but let's not talk about that right now. That's an interesting other session. All right, for the security aspects of your workflow runners, you need to think about, especially when you're hosting them yourself, otherwise it's being handled by GitHub, is what is the scope that the runner has access to? What part of my network does it have access to? Am I leveraging network disks, for example, or shares that I need access to get something and to make my workflow run? How does it have access to the disk? Can I share a cache somewhere between runs? And would I even want to do that? So when you are running a self-hosted runner, you need to think about these things. And the best thing I can say is really, really tie down the access of the user that the workflow is running on. And I've got some examples further on this session, and we'll learn why to do that. But you need to really think about what you're doing with GitHub hosted runners. All right, a best practice here is even limiting the blast radius further, not just tie down the user that is running on, but run the action itself inside of a Docker container. You can do that here on the step part. I'm using it in my first step. Anything that I run inside of that step uses a specific Docker container. It will be executing that container that will do the work for me, and the output will be available in the next step. And this way, I'm limiting the access that the action has access to, for example, the network or the disk access, and I really can tie it down with an extra boundary of being the Docker container. You can also do that on the job level, and here you can see an example that I'm using the OpenJDK image that will be pulled down, and all the steps beneath that will run inside of that container image. First, what you need to be aware of is that that runner has access to anything that you have available. For example, when you have a public repository and you use a self-hosted runner, what could happen there? Well, what if, for example, I have my repository, somebody creates a new fork for it, they may add some malicious code, maybe even changes to the workflow file or a third-party package that they added, and they create a pull request to my repository. Well, will then my workflow be executing on my self-hosted runner with any arbitrary code changes in them that I haven't reviewed, that somebody on the internet made for me? So as a best practice, never use a self-hosted runner for public repositories. Make use of the GitHub hosted runner for you. It will give you a clean environment with each run, and it's not running inside of your network boundaries, so that's a lot safer for you to handle. And of course, probably you can expect that GitHub has a better security and operations than you as a user have. Same goes with persisting data between runs. What if you have a run that downloads some dependencies, it will build your code, and then somehow during the build, an artifact of a package, for example, or a shell script overrides your dependency cache. All of a sudden, you're now running with the second run. It will use the cache dependencies, it will build your code, and all of a sudden you have malicious dependencies in your build artifacts. And what if that the third run will be a different workflow, but running on the same runner? It could even still use your cache dependencies, and then that artifact will be toast as well. And you might think, well, this is a little bit far-fetched. This will not happen to me. Well, this is exactly what happened with the SolarWinds attack. If you go to that short URL, you'll learn a lot more about it and what happened. Be aware that this one is case sensitive, so the capital S matters. But this is exactly what happened. They made sure they could have a way into the build system, add an assembly somewhere in the zip file that they were creating as an artifact, and all of a sudden they had some malicious code in their end product that was being deployed at their customer sites. So this isn't just as far-fetched as you might think. It's a real actual danger that you have when you run actions, especially if you're running them on your hosted runners. So do something with ephemeral runners where you get a clean execution environment each and every time that you run. From a security stance is really important. And as a best practice, therefore, even don't share runners. You might be tempted to say, I have a really beefy virtual machine and I can install 5 different runners on the same machine and share that between repositories, organization, and then leverage some caching on disk, for example. Well, that's very scary, as I've shown you. The first one could easily influence the second one. And it's not just about injecting something in your artifacts. It could be a malicious program, adding a Bitcoin miner in your JavaScript libraries, or even a virus that encrypts your machine, and maybe even the entire network after it's done. So think about what the runner has access to. Also think of any information available on runners. For example, the private SSH keys that you're using to log into GitHub, or API access tokens, or the deployment credentials that you need to deploy into the cloud. The runner could potentially have access to that information, and it could do something with it. So be aware of what you're doing with the runners. All right, let's talk about running the actions themselves and the security aspects of them. You've probably already seen actions, and you know that there's a marketplace for them where you can search for something that you need to do, read the instructions there, and find out what happens. And if you then go to use the latest version, you can go and you get a pop-up and it says, well, if you copy and paste this code over into your workflow, then you are good to go and you are using this action. The interesting part is that the users part of your action is the direct URL to the public repository of that action. So that means you have a way to go to the repository and actually verify what the action is doing. So you can always copy that user's part over, paste it behind github.com, and then you can look at what the action is doing. Why am I saying this? Well, because I already mentioned it, you're running arbitrary code from a public repository on the internet. And if you're doing that on an enterprise setup where you're using local runners, for example, behind your network firewall, that's very scary. You're really just pulling in arbitrary code from the internet and you're letting it loose in your network. You need to think about different attack factors that they have. I already mentioned data integrity breaches where you do something with your caching, for example. But it also goes so far to think about data theft. Maybe you have a malicious action in your workflow that you don't know about, and it leaks or steals your API codes or other secrets that other legitimate actions are really using, and they need it. We already mentioned the build artifacts, but you can also think that the job interacts and compromises the next job to injecting environment variables, files on disk, or even directly interacting with the Docker setup. And maybe they can even break out of a box there and inspect other containers running and executing commands in them. But also think about availability. A malicious action crashes on purpose during a run, and all of a sudden your workflow cannot execute anymore. Well, these days, I hope everybody's doing more and more DevOps, and they're pushing their code into production with a workflow or a pipeline. And all of a sudden, your pipeline cannot be run. Well, if you have a good security setup, then probably you don't have a really easy way to go to production and deploy your latest changes. You could even go so far and think about that an attacker figures out you have a 0-day on your production environment, and all of a sudden they flip a switch and make sure that your workflow isn't running anymore. Or it will trigger something that runs on 100% CPU, and then nothing else can run on that same runner again. And now all of a sudden you're blocked from pushing to production. So that wouldn't be very helpful. Let's talk about some measures that you can take to protect yourself against it. This is an example of a totally non-harmful, you must have an action. This is the best one, of course. It only wants your secret. Well, this is hosted on a public repository. It's not listed on the marketplace. But if you know that URL, you can go to the repository and both use it, but also inspect what it's doing. If that action repository has an action.yaml file and it works, you can use it in your workflow. Of course, this is the action that gave me the inspiration for adding a space after every character in your secret, and that way leak your secret out into your log file. But it's very easy to find something, copy and paste the code over, and all of a sudden you're pulling in a malicious action into your workflow. So what can you do to protect yourselves against it? Well, it's a manual step that you can take is to make sure that you know what the action is actually doing. So go to the repository code, verifying what it's doing. Is it starting up a Docker container? Is it pulling in third-party dependencies? Is it pushing data into a third-party API? But check everything that is inside of that repository, of course. You can check all the container images, even all the layers in there. Everything can be seen because it's a public repository. So what else can you then do? You could say, well, if it's listed on the marketplace, maybe that's a safe then to use. There's probably a process around it that GitHub has when you push it to the marketplace, that they do some verification that you're not doing anything malicious. Well, I checked it out and even tried to, or even added my own Hello World action to the marketplace, and there is no real verification process that I can find. There's nothing publicly stated that they do a scan on anything. It's just a list of actions that you can use and search on. So trusting everything that's in the marketplace is not a good, not a good option. What else can you do? Well, you could say that, hey, there's a verified creator badge on each of those actions that have been published by a verified creator. And maybe that's a secure way to do things. There are a lot of verified creators on site, the marketplace. Last time I checked, the first 5 pages only contained verified creator actions. So I had to go to the Z to even find something, the Z. And I started diving into, well, what's the process then to become a verified creator? Well, only thing that I can find is that GitHub states that the author is a partner that GitHub has closely worked with no explanation whatsoever. So if I cannot see what that process is, it's not something I can trust. So my advice is don't look at too much of those things. Go with the verified creator name. If something is being published by AWS itself or Azure, that's probably a better way to look at things. What more can you do? Well, of course, you can say disable all the actions in my organization or repository whatsoever. Then nobody who creates a pull request can add something there and do something with it. Well, of course, that's not very helpful. We still want to have a DevOps pipeline that does something for us. What more can you do? Well, you could say only allow the actions created by GitHub themselves. I'm very sure that GitHub has a good setup for their own repositories where only people with the right access can merge pull requests in, for example. And those users will have two-factor authentication set up and to do some code signing as well. So probably the actions created by GitHub can be trusted. You can also say, and there's a checkbox to say that you allow any action from the marketplace, but as I just explained, I'm not using that one. You can also say that you only allow specified actions. In this case, I have a specific organization that I'm using for all my actions, and I'm allowing all the actions from my actions organization. At the bottom line, you can even see that there are examples where you can say I'm trusting a specific action because I trust the maintainer of that action, or even a specific version of that action that you can trust. And you can set it up at either the repository level or the organization level. So that's already a good step to take. And if you then set it up and somebody uses an action in a workflow file that's not in that list, they will get an error message before even the workflow is run. That states, hey, it's not allowed to use it. Go talk to somebody with enough access to either change that or update the action that you're using. So it's very helpful. Well, what more can you do? Luckily, GitHub recently changed it so that when you're using the editor in the UI, you have to use a version in it. But if you push code from your local machine, you can use You can still use actions that don't have the versions pinned to them. You can pin the version by adding an add and then the version. It's following semantic versioning here. And you can say, well, I have verified the action repository for version 1, and I'm trusting that version. Well, the hard part is this version is derived from a Git tag inside of the repository. And if somebody adds new code to that repository, they can then tag that same code with the same version number. So even though you have verified that version 1 was okay, the next time you're running the workflow, there still might be some new code being pulled in that you haven't verified. So I'm not liking this option so far. And at least that's a lot better than just use the latest version and go with it. The best practice here is to pin the commit SHA from the hash. Every time somebody commits something in Git, there's a unique SHA being generated, and that can be, you can only generate it basically once. And it's very hard to create the same SHA with different code. So if somebody adds new code to the repository, then the SHA hash will be different. And you know for sure that when you use it with the SHA hash, you will not pull in any new changes. It's very hard to create the same SHA hash with different code. And as a recommendation, it's even better to limit it to only local actions or actions in a specific organization, and then fork all the action repositories to them. Make sure you have a separate organization even to test those actions in before you start forking them. That way you can enable your DevOps teams to have the autonomy to take care of whatever inside of those repositories. Got an example later on in this session that dives a little bit deeper in it. But keep that in mind, fork the action repositories, verify what the code is doing, and then only use your forks. Because what do you need to think about when you're running your workflow is that somebody could create a fork of your public repository and do something with the workflow, but there's also an attack factor that comes from the common fields that you can use in the workflow files themselves. For example, when you have a public repository, you have 3 different triggers here. The first 2 are rather safe to use right now. It used to be that pull requests had some different meaning, and that's why they created a pull request target. The push and pull request trigger is rather safe to use because it runs on the merge commit, so the incoming code and not the destination. And it has read-only access to your repository. The pull request target has more rights. It has read and write access, so it could write something back to your repository. And it has access to the secrets. So if somebody creates a public fork, adds a workflow file and triggers something, and then it could potentially share your secrets when you're running it on pull request target. And that's the new standard. It used to be that pull request already had read and write access, but that was way too dangerous from a security stance. So that's why I created the pull request target. Using this setup as general guidance is don't use the pull request target to check out code, build or run the code at all on pull request. Always add an extra validation step, a different workflow that runs on pull request. It does some basics checks to make sure that nobody's touching your workflow files, they're not adding actions in, or they're not changing your third-party libraries. You can have multiple steps there, or even a manual one that says, hey, some human needs to look at this and verify that it's good. And then label the pull request with, hey, it's safe to use. That can be picked up by a secondary workflow that will then have, that can then run with a pull request target setup that has more access rights. External contributors don't have permissions to assign labels on your pull request, so that's a nice gate to keep the bad stuff out, of course. If you want to know more, go to this short link, and there's a lot of explanation here how GitHub runs capture the flag events, where they set up a repository that might have a vulnerability in it, and then everybody tries to pwn that pull request. We've seen some great examples in here where somebody injects some code into the pull request, breaks some security boundaries, and all of a sudden has write access to your repository. We've even seen an example of somebody using that to then create a pull request that will fix that security leak vulnerability in there as well. So it's a very interesting read to learn more about this setup. This all comes from the common fields that you can use in your workflow file. The issue that's being created has a title and a body, and that's user input. And as we know from software development, anytime you have user input, you cannot ever trust it because they can do weird things with it. This is the list of fields that you have from the incoming pull request, for example, but even the branch name in Git could be leveraged to do something weird inside of your workflow file. So if you have input fields coming from a pull request from a user, don't trust them. An example that I can give you is this is an action that we're running, a shell script that uses the GitHub event, the incoming issue title, and we do something with it. And then somebody injects this as a payload with an extra double colon in it, and all of a sudden my title is now A, and the rest of that part is being executed, interpreted by my shell and echoing test out into my log files. So all of a sudden I'm now doing something like SQL injections basically on the shell itself. The way to remediate against this, and the orange parts here are interesting, is inject the title that you want to use as an environment variable. Those will never be interpreted by your shell. And then it's the value in there that you can use. And then still string escape it in your echo command when you're doing something with it. Now you have made sure that you have cast that into a string. So it can only be used as a string. It will not be interpreted, and that's a lot more safe to use. Again, there's an interesting read on untrusted input that links you to a GitHub document, and that explains a lot more on top of this. All right, looking at the time, let's continue with forking actions and making sure that you stay up to date. Well, forking actions, as I already said, is best practice. Fork it to your own organization or repository. I'm using my own organization for that. And then in your production setup, limit it to only using local actions or for that specific organization that you're using. It has some pros and cons, of course. The pros is it's a lot more secure. You have a verification point where you can look in the action, see what it's doing, then verify it. But it also means you now have a backup of the action repository. Maybe the publisher of that action all of a sudden decides they don't want to work on it, and they move it to somebody else who will take over the maintenance of that action. And all of a sudden your workflow isn't working anymore. So it's a good way to protect yourself against those changes. It has some negatives as well, of course. It means that you have more maintenance work to do. You need to create a fork, you need to create a security setup around it, it needs to be up to date. And then, well, how do you set up a process in your organization that your DevOps engineers still have a way to test out incoming new actions that they want to use? And how to communicate that with the users? Well, making sure that you have them and keep them up to date is part of the next and the last topic of this session. How do you make sure that you stay up to date? Well, you could look at the marketplace and try to find out if there's something new that's interesting, but there's no real RSS feed for that marketplace. To make sure that I stay up to date, I created the Twitter bot for that, that every couple of hours checks the marketplace and then it tweets out new actions or actions that have a new version available. From that, I already learned lots of new stuff and incoming tech or new languages that I never have heard of. So it's a very interesting feed to follow. But of course, that doesn't scale. So what else can you do? Well, you need to make sure that all the action versions are up to date in your workflow files. And I have two ways to do that. Both of them start to review what the action is doing. If there's anything you're taking away from this session is to make sure that you know what the action is doing. And then as first step, you can use the SHA hash and dependable to keep up to date. If you have this set up in your workflow file where you use the SHA hash on the action, you can set up dependable by adding a dependable YAML file to your repository. And in this case, it's a dependency of your workflow. The package ecosystem is called GitHub Actions, and you can say scan my directory that I give you daily for any known of any new updates to those actions. It will go back to the original repository, get the latest version, including the SHA hash, and if it's newer, then it will send in a pull request with the new SHA hash for it. And you can then review the release notes of that incoming change, and that's a way to keep up to date. There's an example of this one in my own repository. That's my GitHub tag for the .NET Core web application, and it's sending in a pull request that says, hey, I found a TRX parser action, and I want to bump it from 0.3 to 0.05. I can view the incoming changes in my YAML file, and in the conversation file, I will also list the release notes if the action publisher is using release notes. So you can see what they said the incoming changes were. Well, it's still not good enough for me because I'm still updating my actions with arbitrary changes that I haven't reviewed. So in my opinion, the better option is to fork the action repository and have a good process around that to verify what's in there. In this case, I have my own organization -actions, my user tag -actions, a test repo in there. I could then say, well, hey, how do I get notified of changes in my parent repository for this fork? Well, you could do that through the UI, but of course that is not the way we DevOps folks work, and we need to automate that as much as we can. So to do that, I created a specific repository that you can fork, set some parameters up in there, and then everything is automated for you. It contains a scheduled workflow. It will create an issue for you. You have an opportunity to review the changes. You can then label the issue and pull in all the incoming changes. So this workflow will run on a daily basis, and then we'll create a pull request of an issue for you that says, hey, the parent repository has updates available. Click on the link where you can actually view the incoming changes of the actions code. So not just the release notes, but the actual changes. So you can verify them, have a good look at them. This could be one of your DevOps engineers that's doing that for you. And then you can add a label to the issue that says, hey, I've reviewed this code. It looks good to me. We can use it. And then another workflow will be triggered, and that will update the fork for you, inject that information into the issue itself, and then close the issue for you. So now most of the things of keeping it automated, it will create an issue. It will leverage the notification system of GitHub. Everything is now automated for you, except for the manual check that you still need to do to verify if the security risk with taking in the changes is fine. Working this way has some benefits. You, of course, still have the backup of the action, but you also have full control over any updates that you're pulling in. You have a central setup to pull in updates and manage and authorize any actions that you use. So you can leverage your DevOps teams for that and give them the opportunity to make those decisions. And you can then, in your production environment, say, I only want to allow actions from my actions organization. It also means that you can skip the commit SHA lookup because you have a security process in your actions organization where you don't have to use the SHA hashes. You can always use the latest version unless you really want to use a specific version to prevent from breaking changes. And if you don't use the version or the SHA lookup, all of a sudden you can skip adding Dependabot in each and every single repository to make sure you're up to date. So you now have a centrally system that works a little bit better. All right, we still have 3 minutes left to wrap up then. We've talked about repository security, the runners, and the actions themselves. And I gave you a good way, and it's my best practice these days, of forking the actions and making sure that you have a process to keep up to date as well. So to summarize, these are all the best practices that I mentioned. Make sure you treat your workflow secrets very carefully. It's very easy to still leak them out somewhere. Review the action source code that you're using. Still, should be the single most important point that you're taking away from the session. Review what it's doing for you. You can still pin the action commit to the commit SHA and have a sure way that you know that what you are running is actually something you have reviewed. Never trust incoming pull requests on public repositories. It's user input, and in this case, it's from the scary internet. So be very aware of what you're doing with them. Fork the action repository, only limited to the actions organization that you created for it. Still have an extra additional organization set up to test with, and have a good way to keeping your forked actions up to date. The links are in this slide deck, so I'll share that later on. And with that, I'm ready at the minute. That's very nice. So thank you so much for listening. I hope you learned something from the session. Reach out to me if you have any feedback, or use the chat for that as well. If there are any questions, please let me know. Thank you so much.